Alright, the midpoint formula. In this lesson, we're still in Sullivan's Precalculus, section 1.1, and we're at the very end now. We did distance formula, we did how to plot points on a Cartesian plane, and now we're learning about midpoints. So what is a midpoint? Well, if we find the distance between 2 points, these white points here, and the distance between them is this dark purple line, we can also find the midpoint, the point of equidistance between these 2 points along the closest distance between the 2 white points. So how do we find that exactly? Well, the midpoint formula may seem a little hard to memorize, but I have a really easy way of doing it. The midpoint really is just the average of the horizontal distance and a combination of the average of the vertical distance. So your midpoint should be around here and here. This is the average or the center of the horizontal distance, and this is the average or the center of the vertical distance. So vertical distances involve the y's and the horizontal distances involve the x's. So the formula, now if you think about it like this, is actually really easy. The formula is actually a big coordinate point, okay, with your parentheses and your little comma. And how do we find the average? We add up the points and we divide it by 2, right? So let's say this is x1, y1, and let's say this is x2, y2. Okay, so we add up the points and we divide by 2 to find the average. So with the x's, we're only going to use the x values to find this average point. So x1 plus x2 divided by 2. And then to find the vertical value for the midpoint, or the vertical average of these 2 points, you add y1 plus y2 over 2. It's just the average, the mean. So for example, let's apply all this. That's the midpoint formula. So this is equal to midpoint. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, this is x, this is y. Alrighty, let us use cyan. So let's say we have a point at 1, 1. We have a point at negative 1, 2, 3, 4, 5, 5. No, that's too easy. Negative 5, 3. So, negative 5, 3, and 1, comma 1. Okay, so that's good. The distance between these is this. And we're looking for the midpoint right here. So we don't know what that is. But we're going to find the average of the height, and we're going to find the average of the width between these 2 points separately. So the average of, remember, this is always your x, this is always your y in a coordinate plane, rectangular coordinate plane. So we'll start with x. We'll do the x's added together, so 1 plus negative 5 divided by 2, and we'll do the y's, 1 plus 3 divided by 2. So 1 plus negative 5 is the same thing as 1 minus 5. So negative 4 in the numerator. Wow, that's really big. Alright, so negative 4 up here. Negative 4. There we go. And 1 plus 3 is 4. So 4 up here. This looks like a really nice midpoint. Negative 4 over 2 simplifies to negative 2. And 4 over 2 simplifies to 2. And actually, wow, I could have just looked at this and said negative 1, negative 2, 1, 2. So this does, it makes sense that this is negative 2, 2. I did it, wow, I placed that point really good. Very accurate. So just for fun, to end off this video, let us find the distance using the distance formula. So really quick, I'm just going to put the formula up here. y2 minus y1 squared. Okay, so our points are negative 5 to 3. So x2 will be, I'll say 1 minus 3 squared plus 1 minus negative 5 squared. So minus a negative becomes plus a positive. We have this is equal to 1 minus 3 is negative 2 plus 1 plus 5 is 6. And this is the square root of 2 squared is 4. 6 squared, 6 times 6 is 36. So 36. 4 plus 36 is 40. Square root of 40. I don't believe that's a perfect square. So you can simplify this to 20, 2, 10, 2, and 5. So you can simplify this to 2 root 10. Or you can write the approximating decimal, which is 6.3246, about. So that's the distance between these. That's the distance between these 2 points, about 6.3246, and we found the midpoint, which is negative 2, 2.